So now we can create more variants and add more content to our variants so it becomes more interesting. But there are a few things that we can improve in the how it already looks. So if we take any of these variants, I can show you a little bit of an issue here. So let's take buildings and just pick a new building. And let's find some, yeah, let's take this one. So if we take this building and we put it towards this side, so we want to fill up our level sort of towards the edges with probably some large objects, because it will not be like correct from a realistic perspective, but it feels good in the game world. So we have a building here, D, and let's just rotate it. So if we put a large bunch of trees outside here, it's actually going to feel quite good when we're passing them, and it will look cool. But since the object is very tall, it will just pop up. So it won't look very good when we're running the game, because stuff appears out of nowhere, which our brain sort of triggers to find as glitches. So if we're running our game here and we have our sections here, then we can see that, okay, now it's actually going to pop up. See, there it popped up. And if it's even larger, let's actually make it even larger. So where were I? Prefabs, endless section, more houses, right? So let's make it like ridiculously high, like this. Maybe this. Then we can actually see a bit of that problem more. So when we are running our game here, we see that, okay, we have our house, and then it just appeared out of thin air. And especially if you have mountains or big objects, I don't know, it just looks bad. And of course we can put some kind of fog that obscures it, but it still doesn't feel good. And if we have traffic that is coming against us, they are going to pop up here, and our brain is actually going to look here, or our eyes, and we're going to be focused here, but we see all of those things, and our sort of brain is wired to find those type of faults. So we can do a bit of a trick to actually make it feel a little bit better. So in the real world, when we are looking at the horizon, it is curved. So our curved horizon will make sure that when we are seeing a new object, it just doesn't pop up. It actually grows slowly upwards. So we can see just the first part, like of the top of a building, and then as we are going further, it increases in height, or because of the curvature of the earth. And we don't want to create curved objects, because they're well, I think they're a mess to handle. You could curve the whole world probably and use that, but there is some other neat small tricks that we can do. So I'm just gonna, why do we have a car and well, okay, so I messed up the folder structure, so let's just fix this. There we go. So now we can actually create a new object or new script, and it's going to be an endless part of the endless scripts. And what we'll do is each section needs to have its own script. So let's create a script for that, and this will take care of handling that section. So let's open that in Visual Studio. So the endless section handler will take care of each section. So one section, to get this curvature effect, we're going to make sure that the section that is way ahead of the player is going to start at a lower y value. So it's going to start like at a -100 that we had when we created our endless level first, but I removed it and put it to 0. So we are actually going to start here. Oops, now I moved my code. Endless level handler. So when we are instantiating our object here, we are going to put the position to -100. Oh, -100. And then in our sections handler, we need to track again where is our player's car. So we already did that, but then we need to actually find it. So let's do it the same way that we did it in the endless level handler. And then in our update function, we are going to do some, well, smart things. And again, we are running this in the update function, which means that we are actually updating it every frame. Maybe you should use a coroutine because we are going to raise each section. So the section here is going to move upwards, and when we're moving upwards, we are also updating all of our colliders, and all our houses and objects that we can collide with have colliders. So that will be a performance issue in Unity, and it depends on your device. So if you're running it on a very sort of weak device, such as Nintendo Switch, then that is probably something that you need to take into account. But with the limited number of objects that we are going to have, I think it could still work. And visually, it looks the best if we can run it in the update function. So we will calculate our distance to the player. So we'll just take the transforms position Z minus transforms position in the Z direction. So then we know what the distance is. Then we are going to lerp it. So we are going to lerp it. And we'll take 1, because that's 100%. When we have reached 100% of our lerp, it moves from 0 to 100. So at 100% we are done, we have reached position 0. So we are saying that, okay, the distance to the player minus 100, because we want the ground not to become 0 as we are exactly at it. We want it to become 0 ahead of the player. So 100 units ahead of the player, it's going to hit like the flat part of it. So we have our lerp percentage that is going to go from 0 until 1. All right. And then we just make sure that it's within 0 and 1. So it can't go above that, and it probably shouldn't anyway. So then we will lerp our position of our section. So we will lerp the position, and we will take our transforms position X, and then actually minus 10, minus 100. And then we will take the Z direction, and we will move it until the same position X to 0 and Z direction. And then we will we'll use our lerp percentage. So this will move the objects around and up. So it will make sure that they are raised. But there is one part here. When we are getting our first section, this works well. But then when we are looping it around, then we actually need to put it at minus 100. And maybe minus 100 is a bit big. We can actually see when we are running our code. So let's save that and try it in Unity. Right, so let's take our endless base, open that up. Oh, is this the base? No, it's not. Prefab, endless section, base. And let's assign our variable, or no, not our variable, our script, our endless section handler to it. Go back, save, hit play. Okay, so then we have our C, now we're getting this sort of raised effect when we are moving ahead, and yeah, it is going like super fast because, well, we have a -100, so let's actually move it to the side here. So let's have a look at what's going on. So it's starting way down here, so that's way too far. That's why we're getting this fast popping effect, because they have to move up very, very quickly. So it's a bit too much actually. So maybe 10 was a better value. So I will go and change that value to 10. And actually, let's do it together. So our section here, position, will start at -10 instead. And our section handler is -10. And there was one more place, of course, that we needed to change it, and that's the start. So this probably is a great idea to put as a global constant that we can change from one place instead of doing this. But that's fine. Let's save it and try it in Unity again. Alright, so now it should move up slower. Actually, let's bring back our object here, and where are we at? There we go. So if we look at our structure now, we can see that, okay, they are getting moved up slower, and they are starting at a lower, at not so low as before, and we might still have some type of maybe popping effect for these huge, really huge buildings. And yeah, so either you need to reduce those super tall buildings, or you need to make sure that this pop-up effect is starting at a lower position. But that's, I mean, I think this looks way better. And some of you might say that, yeah, another solution is just let's increase our sections and make sure that our camera is rendering further away. And yes, that will make sure that things are smaller, but you still see the popping, and especially if you have a huge mountain, it's going to pop into view and it's going to look strange. So this technique solves it. And actually, when we are talking about our camera, we can reduce the rendering distance because we don't need it to, well, render that far ahead. So we can probably, if we look at our, let's put it over here again when I think about it. Let's have a look at the culling of the camera. So the camera right now is going through all the way here, but our endless sections are ending there. So do we need all of that? No, we don't. So instead we can reduce the size of the camera. From a performance perspective, it doesn't matter that much, because nothing is here in the way, so it shouldn't take up that much performance. But from a sort of said fighting direction point of view, it does matter, because the smaller the clipping plane we have in far, the less or the more accurate it will become. So we can reduce this, and as I said before, it doesn't matter what we change here because it's driven by a virtual camera. So we need to change that inside of our camera instead. So let's change our far clipping plane to 300, and that should be enough to contain all of our content. So if we have a look now, we can see that, yeah, it's within the view, and it works. So that's better. Okay, so now that we had that, we can continue with filling out our level with more content, and we are going to create some large trees to the side here that fills up the view of the player, so it doesn't feel like the world is ending here. And we will create a new child object here and call it trees, and under it we will actually create another child and call it trees. Trees far away. So the trees to the edge here are going to be very large. They are not going to be realistic, but they are going to do a nice job with just filling. And we don't actually need them to be cast shadows either, so we can disable that. And for that we want to use some nice green trees, but in the provided asset there is actually no green, and well, we selected green for our level, so we want to use that. I have, however, made a green FBX already of this orange one, and let me just show you quickly how you do that. So I've created a Blender file here, but that's the same as you would import your the tree as an FBX here. And then you very quickly go into edit mode, and we want to select these sections here, but the easiest way is to select the tree trunk first. So let's hit toggle X-ray, make sure that we're in the face select mode, and then select, hold on, there we go. Well, let's hold in shift so it selects all of them. So now we've selected this bottom part, and let's toggle X-ray off and select these parts up here. So now we have selected the tree trunk, and let's just invert it. Select invert, and now we have our nice leaves. Then we go into UV editing, and in the UV editing we can see that, okay, we have these three here, and if we just do grab with the G button and move it with X, well, with the mouse, we can move it where we want. So let's say that we want to have a pink tree, and if we enable shading, we now have a pink tree. So that's how I made the green tree, and well, now you can do your own trees with whatever color you want to. So perfect. Then we export it as an FBX, or we use the Blender file. Okay, so that's how I got my FBX green tree here, and let's add it in, orange, green, medium, and let's make it a child of that one. And then let's just see that it's on 0. Yes, it is. And I think we can keep the size as it is. And let's just disable cast shadows. And then we want to make a prefab out of this, so it's easier if we decide to change stuff later. Trees. And pine tree, let's actually add here. Alright, so now we have that as a prefab. So I can then duplicate this and add a couple of those, but it's going to take quite some time to do it, and they are all going to look the same. So we want a way to sort of randomize this so it feels like each tree is more unique. So for that we're going to create a little script that handles it for us. So let's go on the scripts, and let's make a new folder, call it utils with an S, and then create a new C# script, randomize object, and open it in Visual Studio. So in this script we want to rotate objects and scale them so they become unique. So let's add serialized field, local rotation minimum, local rotation maximum, and let's do the same thing with our scale. So we call local scale multiplier minimum, local scale multiplier maximum. And then when we are starting up, we are changing the rotation and saying that it's going to be from quaternion Euler. So we're creating an Euler and random value from range, the minimum value, local rotation min, in the X to local rotation max in the X, and the same for Y and Z. So then we have a random rotation. And then we do the same thing for our random scale. So we have our transform local scale, and we put that to whatever it was, and we multiply it by a random range between the minimum multiplier and the maximum multiplier. Okay, and update, we can remove that. So if we have this in start, it means that it makes it once and then it's done. But instead we can change this to on enabled. So on enable, not with a D, on enable will be called whenever this object shows up, and it's going to be disabled and enabled, because when it's not in view, it's going to be disabled. So this on enable is going to get called whenever we're showing a new section. So that will make sure that it feels like a total new, well, not total, but at least it will feel a little bit different than the last one. So let's save that and go back into Unity. So let's take our randomize object and use that. So let's open our prefab. Let's save that and use that. Then we want to provide some random values that each of them should have. So we can go like -10 to 10. So it will rotate in the Z direction, and then the same, or in the X direction, and the same for Z. So let's go -10, 10. And then on the Y side, it can rotate 360 degrees. And then we have our local scale between 0.8 and 1.5. So we can leave that and try that. And then we just want to add a few more of these. And I think actually we are going to stick them slightly into the ground so we don't see their tree trunk that much, because we don't want to do that from the side. And then we can duplicate it and move it to this side. So there is one cool feature in Unity that is a little bit hidden, but it's about scattering objects. So if you want to scatter these objects and don't want to change everything manually, you can select all of them, and then on the X, type plus equal, and then R for random, -3 to 3. So that will move our objects between -3 and 3. So I can increase that to 5. So that's a quite cool way of scattering things in Unity. So plus equal R -3 in 3, and it moves. So cool. Just make sure that they're sort of towards the side. All right, I think that's good enough for us. So these are our outermost trees. So let's save that and then hit play. And we should now have some trees towards the end of our map that are really big. And they are meant to fill out the level, so we don't see that much of well, the sky, and it doesn't feel like it's actually ending there. So I think it looks okay. If we look at like the popping of the trees, it doesn't appear to do that. So I think this will be okay. I will just bring them down a little bit more actually, so we don't see any of the trunks. Save. Okay, so then we can continue with adding more things. So this will be our base layer. So I'm just gonna add in our base things on the side, and the other layers are going to, well, the other prefabs, we are going to use that for other things like center houses, more houses, and then build some bridges. But let me play around a little bit with this, and I'll show you the result instead of spending too much time with you with just fiddling around. Alright, there, now I'm done. I've added a bunch of different sections here, and I decided not to use this one in our random sections when we are actually instantiating them. So we have all of our prefabs here, and let's take it for a spin and have a look. Alright, so I've added this arc that we can see here, or arch, and it gives a nice feeling when you're passing under things. Then you get a more feeling of speed. And then I've added, well, some skeleton things from the Halloween pack, and yeah, some just random things, and I made the houses a little bit bigger. So now we have a quite nice spread in sizes. Everything is a lot bigger than it is supposed to be, but there's a tiny little bug in the system, and if I run this for a while, actually some things are just getting bigger and bigger. And we can see here this pillar is all of a sudden super big, and the skeletons are also a lot bigger than I thought, and now the pillar is even bigger. And some trees here are getting extremely big. So what's going on? Well, I've added this randomization script that I explained before, and it has a feature in it which we'll go through, but let's open it in Visual Studio. So the problem with this code is that we are getting called onEnabled, which happens multiple times as each section is being reused. So this part of the code will actually change our local scale, and if we are unlucky it will just keep on growing, because this value could be, for instance, 2. So the first time we're running it, we're multiplying the scale by 2, and then it's getting reset, and then we're multiplying it with maybe 2 again. That means that it has grown 4 times of the size, and it will just keep on growing. So we need to store our local scale that it had when it started up. So let's add that as a variable, vector3, and call it local scale original, and we'll just default it to vector1. It doesn't matter what we put here because we will override it anyway. Start. And in our start we will take our local scale original, and we will store our transform local scale, and here we will multiply with that value. So that way we will make sure that we are not growing over time, because we are just taking this stored value and manipulating that and storing it as our local scale. So saving that and returning to Unity should resolve that problem. So let's try that again. Alright, so let's get rid of the mouse pointer. So now we can see that, the scale of our objects are better. We don't have that big pillar sticking out on the side here somewhere that we had it before when the skulls appear. So now we have a level that is getting randomized, and well, actually it was quite big, but it's still not as big as it was before. Anyways, so now we have our level, and we can create random content, and of course we can improve this randomization even more to, for instance, maybe we set a script that shows this house sometimes, and sometimes it's disabled. That way we can reuse the same content, and it will feel like it's more unique, that it's not the same thing looping all over the place. So randomization is a lifesaver, and it can help you create less content but make the player feel like it's playing a more of an endless level instead of just the same objects repeating all over the. I'd like to give a shout out to our Patreon supporters. It helps us with every single contribution that we can get. So please consider supporting us on Patreon. The link is in the description. Thanks for watching, and don't forget to like and subscribe. I'll see you in the next video.